This is a continuation of lesson 4.2. This particular part of the lesson will show you how to convert an equation that is in standard form and have it converted to vertex form. Now the forms are given to you in your notes, as you can see here. Standard form is y equals ax squared plus bx plus c. Vertex form is y equals a times the quantity x minus h squared plus k. We do like to have our quadratic equations in vertex form at times so we can identify the vertex simply by looking at certain parts of our equation. So what we're going to have to do here, we basically are going to rewrite this vertex form and replace the a, the h, and the k. That's our objective. Now the easiest one to find is a. It's simply the coefficient of your x squared, which is 1. So we put a 1 in place of a, which you wouldn't really have to place there, but we'll put it there so you can see what we actually slid over. Okay, then you take and replace the h. Now the h is nothing more than the x coordinate of your vertex, and this formula, negative b over 2a, is going to be used quite often in this lesson, in this case to find the h value or the x coordinate. And so we'll simply substitute the b value, which is a negative 4. So we'll end up with 2 negatives on top, and then over 2 times 1. Remember, a is 1. And you simplify that to 4 over 2, which becomes 2. That becomes your h, or x coordinate of your vertex. So we put 2 there. And then the last thing we need to find is the k value. To find the k value, you take your original equation here, and remember, k is another name for k is the y coordinate. So y, or if you think of this as k, is equal to 2 squared minus 4 times 2 plus 1, which becomes 4 minus 8 plus 1, which is negative 4 plus 1, which is negative 3. That is your y coordinate, or your k. And remember, that is the y coordinate of your vertex. So if we were asked to identify the vertex, remember we set the guts equal to 0, you would end up with 2. And then the k is your y coordinates of your vertex. That would be your actual vertex of this particular equation. So what is the answer we're looking for? We're looking for this. This equation is identical to this equation in standard form. So now Pearson will take you on and show you how to graph equations that are in this form, and continue our learning about quadratic equations. Thank you.